Okay, right. So, what I want to do today is the content we're covering today is user input, and user input isn't actually that difficult or that large a concept to cover. The fact that we have the ability to print content into string, what we did in week 1, we have the ability to solve expressions or solve mathematical equations in the program, and we've looked at the idea of variables where we can store information. User input is, rather than saying integer x is equal to, and hard coding, writing in a value yourself, so writing 5 or 57 or whatever it might be, user input is replacing that so that you, the programmer, aren't writing values, but the user is, so which it's useful. It helps us on where we're going to go. But the nice thing is, again, we're a third of the way through the semester at this point. And it allows us to take a small bit of a pause. Probably the way we're going to structure this is we'll work up until the break on variable stuff, and I'll go through a lot of worked examples, and then we'll take our break, and then the remainder of the class will be just working through the workshop, or the worksheet question that you have. By the end of today's class, you should be able to do the first 4 questions of the 7 that are on it, and then it'll be 1 question per week as we move forward. Okay? Right. We have some new people in the class, so I'm just going to quickly, I suppose, remind everybody of the structure of my Moodle page so that you can see where we're going. So my Moodle page is structured where I have my contact details, and I'm aware I have forms which I have not used any of yet. I have some basic stuff here. So under announcements, I have a book on problem solving. It's got nothing to do with programming. It's just algorithmic solutions or systematic processing solutions to problems. And they get your mind in the right position for solving computing-related, mathematical-related problems. It's by a guy called Ronald Backhouse, and there's a PDF link to it there. It's a link to silly mistakes that you can make when you're submitting code to me that will end up losing you marks. Don't need to read it yet, but it probably will make more sense after we cover next week or the week after's lecture, when you can have enough there to have content. We've looked a little bit at indentation and structuring. There's a link to that tool I used last week, Jelliot, where you can animate what's happening inside the program, and it'll help you just visualize, get the conceptual understanding of where variables are going. Why are we storing information there? What happens when we put it there? What happens when we change it? How does it get updated? I also have a link to some development environments. Notepad++ is what I use, but also there's Atom. If you're on a Mac, most people use Sublime Text. There is Visual Studio Code, which is from Microsoft, and it's cross-platform. It runs on everything. But there are some kind of quirks to that, so I haven't gone with that. I've stuck with Notepad++. It's free. That's what we work with. You also will end up using the command line for compiling our programs. The reason why I want you to do this is you're on a degree path for the majority of you. You're here for 4 years to get a degree to be a computer scientist. You should be coming out of that program not being terrified when you see just text and have to figure out when there's no buttons and no widgets to click on. You just have to write in a command yourself. So we're going to do a little bit of practicing here on it. And it's it'll be very repetitive what we do. It'll be open up the command line, navigate to the desktop, Java-C to build our program, Java to run our program, and it's kind of rinse and repeat. As we move into 2nd year and 3rd year and 4th year, that will get expanded. You'll end up doing a couple more commands. And it's advantageous to have that command line experience, because there are certain jobs which you live in the command line. If you're a server administrator, so if you work for, let's say, Amazon on their Linux servers, you live in the command line. You rarely see a nice Windows interface like this. Everything's in the command line, and all the automation stuff is done through the command line. As a programmer, the more you understand the system you're writing for, that you're writing on top of, the more you can take advantage of that. You can manipulate the actual system for your own advantage to work out the most amount of efficiency and power from that system. So again, it all builds into that. The course books that I recommend there, someone has told me this link is dead, so I need to update that. This link down here is a link to a book called Graded Problems in Computer Science. It is a book that's been out of print for like 15 or 16 years. but it covers language agnostic computer problems. You're dealing with variables, you're dealing with arrays, you're dealing with loops, you're dealing with if statements. Here are a bunch of tough problems. I'm not going to tell you how to solve them, but they're problems. Generally, I get most of my worksheet questions and most of my exam questions from this book. There's no secret about that. I'm not giving you kind of an advantage over any other prior student. The book is there. You can start looking at it now. If you spend the next year going through every single question in that to get it done, to work at the answer and learn all of those answers, you will be a phenomenal programmer at the end of it. So there is no, I'm not going to, I haven't slipped up and said, oh, I shouldn't have told you that. Go ahead. Please start doing the practicing. I also have a file here on the course layout, which will highlight what we're covering each week, roughly, if I don't get sick or if there's a delay or cancellation, when the assessments are out, when the assessments are due back, when your breaks are, and how much we're covering for the whole year. I have a link here to my OneDrive where I will upload any of the source code that I cover in classes or I cover in labs, so that, again, it's two reasons. One, this is a long room, so if you're at the end of the room, you may not be able to see all of the text clearly. But also, too, I think more importantly, I would value your attention to what I'm talking about rather than you furiously trying to copy down the code to make sure that, oh, it's written down. You don't need to be diverting your attention for that. If you spend your time looking at the content and going, oh, I understand what's happening there, and know that the backup is available online to get, that's probably a better use of your time and your focus. I also have a YouTube channel where I will record, and I'm recording at the moment now, the lectures that I run. I missed the first week, but the first week we didn't cover anything specifically in programming. We talked about problem solving. But on the YouTube channel, I have videos on downloading Java and getting it installed and configured on Windows, running your first program, so physically writing the code, saving the code, going to your command line, running the build command, running the actual run command, and moving from there. And then I have the kind of the archive of the classes that I'm doing, these classes now. And my plan is, unless either the network or the hardware fails me, to keep this up until we finish the semester. So by the end of the semester, when you're studying for your May examination, you will have 24 weeks worth of lectures, which is probably going to be roughly 48 videos to watch, because I'll split them when we take our break in the middle. And then I have the weekly notes that I usually have a couple of weeks ahead. So we are, at the moment, we are just going to be here. And today I'm only going to do user input. We'll come back to other data types later, because that's a very, very quick content, because I implicitly cover it as we go through the user input. And so you can see we're doing next week and up to loops. I'm going to leave it there for the moment. You can see the teacher's view of stuff that's hidden from you, but that'll all be available soon. But I'm going to release up into loops. So you can read ahead up to there if you want, but I want to cover all that content before I start releasing any more. We also have, there's some worksheets for practice, so you can see that I've released a couple of them here. And there's assignments as well, and I'm not going to go any further. We might release the titles of some of the assignments. I don't want you to know just yet. Okay, so that's my Moodle page. Today, what we're going to look at is we're going to look at user input. That's the notes. Right. And that's the wrong bloody notes. Right, never mind. User input, there we are. Week 4. Actually says user input, I just clicked the wrong one. Okay. For the last 3 weeks, we have been slowly expanding what our code, what our programs can do. The reason why we're doing this is we are desperately trying to get to the point where our programs are useful. Okay? Think about the programs that you've written so far. You wrote in the week 1, you wrote the Hello World program. That is an utterly useless program. It's great for learning, but no one ever uses a Hello World program. It's, oh, great. I wrote something, I ran it, and it didn't break, and I can see it's an output. That's all. It's a verification that, is this thing on? Yes, it is. Great. But you can't do anything with it. You can't utilize it. And then we looked at doing arithmetic in the printheads. Okay, so you have your mathematical equation, the volume of a cylinder or the surface area of a cylinder. And that was more work. You were definitely getting the computer to do more work, but still it was kind of useless, because if you decided, oh, I don't want the diameter to be 7 centimeters and I don't want the height to be 10.5, I want it to be something different, you have to open up your Java file, edit your code, save your code, build your code, hope there were no errors. If there were, go back, edit your code, save your code, build your code, and then finally run your code. And for every time you'd want to do a new calculation with different dimensions, you would have to do that same routine. So there's a lot of steps, a lot of work put on you, the developer, at this point. And think about it. Think about before you started this program. I'm assuming nearly all of you had smartphones, or you used the internet, or you had a tablet, or you had some sort of piece of technological hardware that you could download a piece of software, whether it's an app or an actual piece of software which you install, and you'd run it. And you didn't have to do the exact same inputs all the time. You've got a calculator on your phone or on your laptop or on your PC. And you can open that up and you can type in any number you want and any operator you want and any other number you want, and it'll be able to solve that problem for you. We didn't have that. We still don't have that. Okay? What we have at the moment is, as long as the programmer is sitting beside the user, they can go in, they can edit the code, they can rebuild the code, they can run the code. That's a lot of work. And what we're doing is we're moving away from that. We want to move to the point where we have a program that does a task. This program will tell you the volume, the surface area, and the wrapper area of a cylinder. No problem. And it can be set up that way. And it only does those tasks. But once it's built, you can give it to a non-technical person. Okay, you guys are doing it at the moment. If you're on the degree program, you're doing systems analysis with Gemma. Yes? Okay, so the goal of a systems analyst is to be the technical bridge between the client, the non-technical person, who will give you a vague description of what they want as a system, and you have to tease out all of the nuances of that system. And the reason why you have to drag out all of those details and be really pedantic in the way you talk about, okay, and exactly what information you enter in here, and exactly what do we want to hold in the customer, and exactly how do we keep our stock inventory, is so that you can create a technical document that is detailed enough that you can give to the programmer, who can go off and build that system. And the programmer and the client don't ever need to talk to each other. That's the whole purpose of an analyst, to go in, to get a English description, a non-technical, usually vague description of a problem, of a system that's desired, to look at all of the possibilities, all the requirements for the user, so that's your user requirement specification model, to look at what is available. Can we just buy something off the shelf? Do I actually need to go and build software? Can I just charge a consultancy fee, save me paying my programmer for this job, and say, oh, you need Microsoft Office, you need QuickBooks, you need Sage, and then provide them with training and charge them for the training? Or do they need a custom piece of software? And if they need a custom piece of software, exactly what do they need? And the whole point of that, again, is that you're writing this documentation. That's one, it's a contract. We know what the customer wants and exactly what they want, so they can't say, well, no, I wanted this, because it's documented. So you make sure you're not. And if you ever end up doing freelance work, if you end up doing a mixer for somebody, document exactly what you're going to do. Get both parties to sign it. If there's a change, update the document, get both parties to sign the new version. I have been in scenarios on both sides where I've been the analyst and I haven't documented stuff enough. And the users go, no, you said you do this. And because I don't have any documentation to say contrary, we have to go ahead and do it effectively for free. And I've also had the other side of it, where the programmer has misinterpreted my document, and they've gone off and they've built something which is not what the client wanted. And then I got in an argument with the programmer because they wouldn't alter their code to match what the client wanted. So I suppose this is, as a life advice, if you end up doing freelance work for someone, document everything. Even if it's a friend, document it. Get both people to sign it or email it and say, a great thing to do, especially if it's working with a friend that you might necessarily want to give them a contract, is to write out an email going, okay, so just making sure your system you want, and list out all the things. Is there anything I've missed? And when that email goes, unless they reply, you can take it that yes, they've read it and they're happy with all those specifications. But your analyst is the link between the technical and non-technical. We as programmers now, we are trying to get our programs to the point where we can give it to someone who's non-technical. and tell them, well, this program gives you the volume of the cylinder. You just send in the height and the diameter. And anybody should be able to use it. If they can type on a keyboard, they should be able to use it. They don't need to know programming. They don't need to know databases. They don't need to know systems analysis and design. They don't need to know web development or hardware. They can just type some code in and it works. Okay? And that's what our goal is. But we're getting there. We have 3 more things to look at. We have user input we're going to look at today. So we can actually get input in from the user. We have next week, we have conditional statements. And that is asking a question of your program. Based on the input the user has given me, do I do path A or do I do path B? And we can build it up to quite complex structures. And then the last thing is something called iteration or loops. I can get my program to do something multiple times. Okay? And when we have variables, which we have already, user input, if statements, which is our conditionals, our asking our questions, and our loops, we can construct quite complex problems or quite complex solutions to problems. And everything we do beyond that, everything we do after week 6 of this program, will be giving us, utilizing the same 5 tasks, but applying them not to numeral variables, okay, so not to variables that are only going to hold a numerical value, but to ones that are going to hold text. And how can we process text? How can we write a spell checker? It's going to deal with how do we store a group of objects together. It's going to look at how do we have a Java program that can reach out and create or read from a text file somewhere else on the computer or on a website and get information back and update or work based on that information. And so we're gradually going to grow what we can use those 5 elements on. But like I said, once we go past week 6, it's just repetition on those 5 elements until you know them backwards, until you can know when they're useful and know when they're not useful for a particular problem. So let's move on to user input. So we have almost useful programs. What we need to do is we need to add some elements of code into our programs to allow for user input. There are 3 key things we need when we are going to add content into our programs or add user input into our programs. The first thing is we need the command that allows you to drag information in from the keyboard. And that command isn't part of the core system. It's in what's called a library. So very much like the library that's over in the top floor of the Arthur building, a library in programming is kind of the extended knowledge area of your program. So sometimes if you're going to do an assignment where you have to have referencing. Please read this chapter on this book and explain what it means or write your essay on that. So you go off to the library and you go to the right section of that library and you find the right book in that right section and you open it up and you open up to the right chapter in the right book in the right section in the right library. And then you can get the information that you need to actually do the work you need to do. This is essentially the exact same thing. We are going to point, the very first line of our code is going to direct our Java program to a specific point inside of Java to allow us to get access to this library. It would be like me saying, for next week's class, I want everyone to get Dietel and Dietel's book on Java out of the library. So you go up to the library, so you go to the right room, you go to the computing section, you go to the programming section, you go to the Java subsection, and then you look for the Dietel and Dietel book. Okay? So it's like that. You're giving a direction. You're going to need this information to run this program. So the first thing we need to do is we need to incorporate a library into our code. And the way we're going to do this is by using what's called the import command. If you have done programming before, if it's been C# or C++, you would have used the include command. It's basically the same thing. There's some information I need to run this program that I'm not physically writing the code for, and it's located over here. So when you see a command you don't recognize, check the library to make sure that the command is there, and that will give you a definition, a template of how to use this command. It's going to allow our program to gather all of the information it needs before it starts to build the program. Okay? You have, I'm sure at this point, written something, whether it's through a typing error or through trying to access a variable that you haven't actually created yet. You've come across the unrecognized symbol error in Java. It's when Java looks at something you've written and goes, I have no idea what that is. If it's a command, I don't recognize it. If it's a variable, I don't recognize it. So to make sure we don't get that with our scanner, we need to point our program at that library. So the import command looks like this. We have the keyword import, which is telling the program you're going to need to go off into Java and have a look at this file. And I'm going to show you what the file is now when we finish this slide set. It's going to go into the Java library, into the utilities subset or util subset. And then what I'm going to do is I'm going to take everything. This asterisk here means everything. It's called a wildcard operator. If you are searching for something on your Windows Explorer and you type in asterisk.doc, so a DOC for a Word document file, it'll find you every document, everything of that Java or everything of that file type in the folder where you are. If you type, let's say you can't remember what you're looking for, but you know it's a payslip or it's got payslip in the title. You can type asterisk, payslip, asterisk, dot, asterisk, and it will tell you every file where the word payslip is mentioned in the title in that particular folder or any of the subfolders. So it's quite powerful as a command. And what we are saying here is go to the Java library, go to the utilities subsection, and get everything that's in there. And the reason why we say get everything is because for this week, we're only looking at one item inside that subsection. But next week, we'll end up looking at another one. We'll look at the random object, how we generate random numbers. And as we move through the course, there will be other things we need inside that library. So rather than having 7 or 8 import commands, which are all java.util.scanner, java.util.random, java.util.whatever it is, the dot asterisk just pulls in everything. And it allows us to access all of those commands, and it minimizes how much time or how many import statements we need at the top. Okay, so import command we need to tell it we need to get some extra information. This is the location of where that information is, and this wildcard operator here means get everything, which is what that signs there. So in computer science, a wildcard is a special term that means everything. In the case of our import statement, it allows the program to access every feature inside that subsection of the library. So that's the first new line of code we need to add into our program. That is going to allow us to call the command that will allow for user input. The next thing we need, once we've done that import command, we need to actually create the thing, the object that's going to pull the information into our program from the keyboard. And this is something called the scanner object. It's declared kind of like a variable. Okay, so remember last week we had our variable declarations and it goes data type, so int, double, boolean, whatever it might be, name, my counter, my variable, x, y, and then you have equals and then you give it a value. Well, that's for what's called a primitive variable. A scanner is a different type of variable called an object. So the way we declare it at the moment is like this. We have our data type, it's a scanner. We give it a name. I have called it in my slides here because it's for input. To make things a little bit simpler as you move through the course, I'm actually, every time I use this command from now on, I will call it KB for keyboard. And then we say that's equal to a new scanner, and we're telling it where it's getting its input from. So the left or the right, the left-hand side of the equal sign is very similar to what we've seen already. Data type, name. Then we have our assignment value. Here's how we're going to set it up. But the right-hand side is quite new. We haven't looked at something like that already. So the new keyword means that I'm going to force my program to use an extra piece of memory space to create this object. Okay, I want that object to be of type scanner, and I want it to be using system.in. Up until now, if we want our program to put something out on the screen, we've used the command system.out.print or println. And that makes sense. System.out, it goes out of your program onto the screen. So system.in, logically, is how we get stuff into our program. And what we're doing here is we're setting it up, and using system.in here effectively means I'm going to be pointing at the keyboard. We will see another way we can use Scanner the latter half of the second semester, where we don't point it at the keyboard, but we point it at a text file. So it's a way that we can read in from text files and we can kind of process the text that's inside that. But this is the second line of code that is going to be used to get user input. Okay? Our import command tells us where to get the command. This is setting up the input device. And then the third command is actually taking some input in from the computer. So let's put it all together and have a look at it. We haven't looked at how to take it in, but we're going to look at it now in the slides. And then I'm going to start going through multiple examples. So we have a very simple program here. We're going to take 3 integer variables, x, y, and z. We're going to take user input in for each of them. We're going to add them together, and then we're going to tell the user what the total is. This is how the program is going to look. Please enter your first integer, and the underlined text there is what the user has entered in. So the user can enter in the number 10. Please enter in your second integer. The user can enter in 15. Please enter in your third integer, and the user enters in 20. And then the last line there, the total sum is equal to 45, is our program adding up those 3 numbers. If we have a piece of code that uses user input that does that, we can add up any 3 numbers. We can add up 3 negative numbers. We can add up different positive numbers. We can add up a combination of negative and positive numbers. And the calculation works the way it should work. But the nice thing is that once we have this piece of code built, if I want to add up, or if I want to ask 100 people to enter in 3 numbers, which have all the possibility of being different, and to tell them what the answer is, I don't need to ever rebuild or re-edit that code. I just need to run the code 100 times. So before we had user input, if I had 100 people who would want to get that their 3 numbers added up, imagine that's a difficult calculation for these people. We would need to write the code, so edit the numbers to what the user wants, save the code, build the code, run the code. And if we've 100 people, that is 400 actions. What's going to happen now is we are going to, the first time, write the code, save the code, build the code. 3 actions. And then we will have 100 running the program. So it'll be 103 versus 400. Now, as a programmer, that's great. That massively reduces the time I need to spend on this program. I can just build it, test it, make sure the outputs are what I expect, and give it to the users and say, off you go. Now, if they want something different, then as a programmer, you need to go in and you need to change it. But if all they want is 3 numbers added up, that can run for 1,000, for 10,000, for 1,000,000 users. And you would only have to write the code, save the code, build the code 1 time each, and then it's running it for however many needs to be done. So this is what the code looks like. This is the first half. And actually, do you know what? That's quite small text, so I'm going to quit out. This is the last couple of slides of my lecture here. So what I'm going to do is I am going to quit out of this, and I'm going to do it as all through Notepad++, so you can see how it looks. Okay, and I don't need that one there. So I'm going to have, okay, that's as large as I can make the text. I'm going to have import java.util.asterisk semicolon. And just again, this is the first time you've seen this command, and it's a long room, and people's eyesight isn't always as good as they believe. That is a space in between the word import, I-M-P-O-R-T, and the word Java. That is a full stop. That is a full stop. That's an asterisk. And everything on this line is lowercase. I'm assuming you all know that. You're not going to make any mistakes, but I'm just going on what previous groups and previous years have done where they have mangled that line. Okay, so this gives us access to the utilities library. Let me actually save this as, this is going to be user input 1.java. Okay. Then we're going to create our class. So class user input 1, public static void main. For those of you who are new today, for the moment, just go along with what I'm writing. The bits which I'm not highlighting at the moment are stuff that everyone else has covered. I'm going to come down to you in the work period and give you programs to kind of work through this stuff. Okay, so let's go. I need to create 3 variables. I need to take in user input for those 3 variables, and then I need to give them an answer. So I'm going to create 5 variables really in total. So I'm going to create int x, give it a starting value of 0, int y, give it a starting value of 0, int z, give it a starting value of 0, int a and s for answer, give it a starting value of 0, and the last one is the part that's relevant to my user input. Scanner kb is equal to new scanner. That's going to have system.in. Beg pardon? KB. Okay, so KB stands for keyboard. But this is as the comment says, this is the thing that will actually allow you to take input in from the keyboard. So this is the location where that thing is stored. I'm making a instance of that thing in my program, and then I'm going to use it later on, which I haven't done yet, which is actually taking the values in from the user. So I have scanner KB is equal to new scanner system.in and then semicolon at the end. And what that's doing is it's setting up the required elements in my code so that I will be able to take user input in. Okay. So we have our import statement here. We have our class, our public static void main. We declare our 4 integer variables. This will be user input, user input, user input, and this will be the result of our calculation. And then we have our scanner, which is going to allow for us to take data into the program, take information into the program. Now that I have this set up, I can actually run the specific command to say, take in a number. And I have to do it for the integer x, for integer y, and for integer z individually. And then once all that's been done, when I have gathered all the information I need, I can do the actual calculation. X, or answer is equal to x plus y plus z. So this is how this is going to look. So when I'm taking user input, I always want to prompt the user. If you don't prompt the user, and I'm going to show you what it looks like when you don't do it, it can be difficult for the user to work out what they're meant to be doing. I am sure that even though we're all in first year, that you have, through your smartphone or through your desktop or through some digital device, you have downloaded a piece of software hoping that it would solve whatever problem you had, whatever thing you wanted to do. And I'm sure that everybody has had both experiences. You've had one experience where everything's gone smoothly. You got lots of feedback from that piece of software. It gave you prompts of what you should do next and what you should do next and how you should save it. And you went away from that experience going, that was really helpful. I liked that piece of software. I'm probably going to use it again the next time I have to do whatever the job was. And you've had the opposite experience, where you've downloaded a piece of software hoping that it would solve a problem for you or help you to do something, and it was unintuitive. You didn't know what was meant to be, you were meant to do it. There was no type of help or tutorial or guide to show you what step 1, step 2, step 3 is. And you've walked away from that experience going, I'm never going to use that again. That was a waste of my time. For me personally, if I download an app on my phone, it doesn't work, it goes straight off my phone. There's no need to keep it on there. If it doesn't work, or if it's too hard to use, or if it's unintuitive, Why would I keep it there? It's just taking up space. I'm not going to use it, so I get rid of it. We want to make sure our programs fit into the first category. They're helpful. They guide the user. Okay? We as the programmers should know what's happening inside our code. And yet I have every year for the last 8 years, at some point throughout the first year, have a student, both full-time and part-time, so it's not just the full-time students this time, call me down and show me a command prompt screen with a flashing cursor and no information. And my program's not working. As we break out of that and we go in and we run it again. It's just a flashing cursor. And then I go back and look through the code. And they have this line here, line 13. And what line 13 is going to do is it's going to wait until you enter in an integer number. It's going to wait until you enter in a whole number and press enter. And it'll wait as long as it needs to. Now our program is going to be useful because before it starts waiting, it's going to say, please enter in a number. You have told the user what you're expecting. And you assume the user is able to read it and they're able to enter in a number. But very often, when the student calls me down with the flashing cursor, they don't have line number 12. They only have line number 13. And if the developer of that program, can't work out what they're meant to be doing, how is a user who doesn't know how the program's been built and doesn't necessarily know what information is required at what time, how are they meant to do it? So as you're going forward, as you're writing in your programs from now until to the end of your degree and beyond, make sure that you're being helpful to your user. If you're expecting them to give you some sort of input, tell them what input you're expecting. It's really hard for a user to sit there with just a blanking cursor. I mean, again, think back to week 1 that we looked at this. That's all you saw. That's our command prompt. Now we know how to use it now. Actually, where is my cursor? I don't even have a cursor on this one. And we know how to use it now, but if we started from week 1 of programming and going, okay, off you go, guys, and I gave you that, you wouldn't be happy. It's not intuitive. You don't know what you're meant to be doing. It's difficult to use. We don't want to have that. We want to make sure that we have something useful, that we're prompting the user as we go along. So this is how we take in the X variable. We're going to say KB for keyboard, so it's referring to the scanner. We're going to use the dot command here, or the dot operator, and we're going to call a command called next int. That's next, all lowercase, and that's a capital I for int, and then NT for the remainder of int. And then we have empty brackets. We never put something inside these brackets here. They're always left empty. And what that is going to tell the program is the next thing the user is going to type on the keyboard is going to be a number, and you're going to suck it into the program. And when you get it into the program, we're going to place it inside variable X. And the program will just sit there and wait until you enter a number in. So that's an incomplete program at the moment, but let's save it. Let's go here. Oh, look, I have a cursor now. Let's go to desktop. Let's go Java C user input. Let me increase the font so you can see it. There. And then let's go Java user input as well. So this is what I'm left with. I've prompted the user, please enter in a number, and it'll just sit there. And it's much more patient than I am. It will wait as long as it needs to wait. But I'm going to enter in a number now, so I'm going to enter in 12, and I press enter. And since we haven't written anything in our program, that's the end of the program. It takes in one number, and then it quits. It finishes out its actions. But that's where we're sitting at the moment. So that's not enough. We need to take in 3 numbers, and we need to add them together. So let's go back to our code. And I'm going to duplicate this and say for the Y variable and for the Z variable. Now, if you have a look at that code, lines 13, 15, and 17 are basically the exact same. The only difference is where am I putting the information once I've taken it from the keyboard. So the thing I want from the user is the exact same each time. I want an integer. And where I'm putting it is going to be into variable X, variable Y, and variable Z, depending on which line we're at. When line 17 finishes, and we've put that value the user's entered in into our program, that's the end of the user input. We don't need any more user input. So what we do at that point is the program becomes much more like what we're familiar with, much more normal. So it's going to be Answer is equal to x plus y plus z plus z. And then we're going to print out our answer. And that's the end of our program. So we use those 3 new lines of code to alter our program, to make it more useful. Our program now will run and it'll ask the user, please enter a number, and it'll ask that 3 times. It'll be able to take in that number, each of those 3 times, and store it into a variable inside our program. And then at the very end, when it's taken in all the information, on line 19, it can add those numbers together, store that in another variable, and on line 20, print out the value of that variable. Okay, let's test that. So we're going to save our code. We're going to recompile our code. We're going to build our code. Okay, so it's going to please enter a number. So we're going to enter in 12. Here we're going to enter in 45. Here we're going to enter in 2. And it'll tell me that if you add 12, 45, and 2 together, you're going to get 59. So it's a very simple program. I think addition was the very first thing we did when we did a calculation inside our printout statement. We have done technically more challenging programs than this. Think about the cylinder problem. We have to get the volume of the cylinder, the surface area of the cylinder. Think about the number of seconds in however many days, however many hours, however many minutes. They're more demanding. They're more challenging problems to get your head around. So the reason why I picked such a trivial problem to look at today is because I don't want you worrying about the challenge, the actual what the work that the program's doing for you. I just want you to be able to look at the user input. So let's go back through this, go back line by line, and then we'll have a look at another example. Does anyone have any questions at this point? Everyone's happy enough? Okay, so line number 2, that's our first new line that we have. It is going to import our java.util.asterisk library. So it's going to go to that location in Java and have just actually so you can see what that looks like. If I open up my command prompt, I go to a C drive and I go to where Java is stored, and I go to my source, and I go to Java, and I go to util. And look for a scanner, which will be under S. Scanner. There we are. 98 kilobytes. And it is 2,618 lines of code. Exactly. That's the correct response. Because we don't want to write that. We just want to be able to run a couple of extra lines in our program to take user input in. And the reason why that is such a large file, and again, that's one file that if we have a look back here, there are loads of them. This is everything that's inside the util library, where we looked at like a dictionary, or we look at a calendar, or we look at collections, or we look at hash tables, or time zones, or string tokenizers, or stuff which over the 4 years of this degree, you may never look at some of the stuff in this folder. But they're all utilities that through the vast amount of people who use Java as their main development language have felt, hey, this is something that should be incorporated into the core system, that everybody, if they install Java, should have access to this stuff. And that's just the utilities library. If we go back up here, and I know the text is going to be very small, but we have the utility library, the time library, the text library, the SQL library if you want to access databases, the security library if you want to encrypt or decrypt content, and the RMI and the NIO library, the net library. So these are all for networking information. The math library, the language, the IO. We're going to come back to IO at the end of March probably when we start dealing with text files and how we have input output. We have Java Beans, which is a way of getting websites up and running using the Java framework. We have AWT and applets, which are ways of having visual front ends, buttons and widgets and radio buttons and checkboxes and sliders and all that kind of stuff. And we can create all that through Java. And that's the basic lowest end of installation. That's not including the extra stuff that Java, that Oracle, the company who owns Java, would have that you could download that can just be plugged into Java. It's not including the thousands, if not millions, of third-party things that you can incorporate into Java. What if you want a Java program that takes in a whole lot of user input and pushes it out to an Excel file, or pushes it out to a website, or creates a PDF from it? Adobe and Microsoft have created libraries that we can use, that we can incorporate into our program. Programming languages, if they are to work well, need to be extensible. They need to be like Lego blocks. We can keep building on top of them. We can add more things on. We can remove things that don't work as well and add an updated version. And because modern programming languages are built this way, it means that we can, if we come up with a solution to a problem we have, we can create a tool that can be plugged into someone else's Java program that helps them solve that problem, so they don't need to reinvent the wheel. In the same way, this is our user input lecture is a small lecture. We're going to finish in 20 minutes and then we're done with new content for today. I don't need to go through all 2,618 lines of this code. Someone else has done it. I'm not going to make you reinvent the wheel. I'm going to tell you how to utilize it so that we can get content into our programs to use it. Right, let's close that out. So, to get that content, we need our import statement. And that's literally going to go over to that folder, Java, and inside that folder into the util folder, and copy all of those Java files and say, incorporate this into our program. If we were very short on space or on resources on our computer, we could say, rather than .asterisk, you could change that to .scanner. And it would only let you do the scanner object. You couldn't do random, you couldn't do math, you couldn't do string tokenizer, you couldn't do a lot of stuff. But for us, we're on pretty powerful machines. Even if you go to Dell and you buy the oldest machine they have, it's still more than powerful enough to run everything. This is a 5-year-old laptop, still more than powerful enough to run anything and to incorporate all that extra stuff that we don't end up using. Where you would really want to limit it down is where you'd be kind of writing a piece of code to fit on like even a Raspberry Pi is quite powerful, but like a smaller single board computer, like a microbit, and you would have really constrained resources and there's other stuff running. That's where you might want to reduce your overhead. But for us, we can just use .asterisk and then it means one line and it imports everything for us. We declare our variables to store our information. And then we declare our scanner object. And our scanner object is located inside this folder. And that scanner object is what allows us to take user input. Okay? And then we're going to prompt our user, please enter a number. And then on line 13, on line 15, and on line 17, we're actually going to take the values in from the user. And we're going to, if you take a value in from the user, you may as well put it somewhere. So we're going to store it into the variables that we've created prior to this. And then finally on line 19, that was weird. Finally on line 19, we do the calculation. We have all these values entered in for the user, so we're going to add x plus y plus z, and we're going to store that answer in our other variable, into variable answer for A and S. And the very last thing we do is we print out that answer. How do you feel about that? Everyone happy enough with it? Anyone have any questions? You know I'm going to do another example, so this is a good time to get the question.
Just scroll back on this one. Yeah, just to break down that part, the next int.
Okay, so the way, and you wouldn't have covered this yet in computer hardware or in operating systems, because you do operating systems next semester. But the way that you work on getting input in, the keyboard, the computers that we have, the modern computers that we have, even if they say that they're multi-core, a multi-thread, the reality is that they don't actually do a lot of stuff simultaneously. They use a feature called round robin, where they have a big queue of jobs to do, and they are hyper efficient at doing a little bit of work and immediately moving on to another job. So they have what are called time quantums. It's a period of time fixed in the operating system that they'll spend working on each job. So it might be update the clock. I'll spend 2 milliseconds on that. Check the network connectivity. Spend 2 milliseconds on that. Try to compile the code. Spend 2 milliseconds. And let's go job, 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 background, job, 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 background, job, 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 background. And the more stuff you have running on your computer, the more is in that queue, which means that the longer it is before they finish any one job. Now I say the longer. Modern computers are so phenomenally fast that it looks like it's doing things instantaneously. But every now and again, you get to see what happens. You get to see that little bit of buffering. So we've all had, or I've definitely had scenarios where I've had, I might have been encoding a video for YouTube and maybe playing something off Spotify. And I might have had Chrome open with about 15 tabs. And I might have had my Outlook open. And I was typing something in Microsoft Word. And I type and type that. And then I look up at the screen, and the last 3, 4, 5 words are missing. Where are they going? And then all of a sudden they appear. There's like a fraction of a second of a delay, and then it's like someone types them. And what that is that it's the processor has got its way around to that job in the queue and goes, oh, I should do this, and it adds that work in. The reason or the ability for my computer to take in all of my keystrokes as I've been typing and then just add them to the screen when it gets to that job is because the computer has, especially related to anything to do with input, has buffers. And this buffer is like a temporary waiting area. And it fills up with a certain amount of text. And then when it's time, or when a job says, hey, I need what's in that buffer, it will extract it out like a Pez dispenser. Okay? The next int command is pointing at that specific buffer, the one that's related to the keyboard, and saying, the next thing you're getting out of this should be an integer. So extract the integer out. If I didn't want an integer, if I wanted a different data type, let's say I wanted a decimal number, I would go next double, or next float, or next boolean, or next line if I wanted a line of text. Okay? For today and for the worksheet you're going to work on at the moment, you will only have to do numerical values input. But after we finish loops, we'll go back and we'll have a look at text input and how we deal with that. But the next, and then what the word that comes after the next is going to dictate what data type you're expecting to get into the program. Which brings me on to another topic. If I take this code here, save it, compile it, and run it. Now, in all the examples I did for you, can you? In all the examples that I did for you, where the heck is it? Right, enter. Okay, now we're back up to this. I don't know where the other text has gone. In all the examples that I've done for you, I've entered in what they've asked. I said, hey, enter in a number. But if I entered in 12.9, that's not the type of number that I'm expecting. And I know that because I wrote the code and I know it says next int. But this is not an integer number. That's a decimal point number. That's a double for our Java program. So if I hit enter there, I get this crash. Now, what has happened here is the error has started at line 15 in my program, which is, nope, not that one. Line 15 is here, so taking in the second number. It says, oh, you're expecting an integer. Clearly didn't send in a whole number. I didn't send in an integer. So it goes, all right, go back up to the scanner library. It has a look in here. Next int, no, I can't match it to that. I can't match it to that. I can't match it to that. It gets all the way up here and it goes, I have no idea how to deal with this, and it falls over. And the error, the official error you're getting is an input mismatch exception. You asked for an integer and you got a double. Or if I ran it again, I was entering the letter A. Same scenario. I asked for one data type, but I got a different data type. For the purposes of your own sanity, you can assume that for first year at least, you have helpful users. If you ask for a number, they'll enter in a number. If you ask for a letter, they'll enter in a letter. If you ask for a Boolean value, they'll enter in a Boolean value. There will be times where I will get you to write the code to make sure that the number they enter in is between like 1 and 100, or it's a multiple of a certain number, or that it's a lowercase input rather than an uppercase input. But the data type, you don't need to worry about. You don't need to worry about the contingencies. Well, what if they enter in a double? What if they enter in a character? It's beyond what we do in the first year. We will get to the point where you will write a really robust piece of software that they can enter in anything, and you'll just keep throwing back out. No, I asked for a number. No, I asked for a number, until they give you the data type that you want. But for first year, you can assume that you have nice, friendly, helpful users, and if you ask for a number, they give you a number. If you ask for a double, they give you a double. If you ask for a character or for a string, they will give you that. Okay?
Would that be like error handling with throwables?
That's how we will end up dealing with it, but we won't do that in first year. The exception handling stuff we look at only when we absolutely have to, which is with text files, and we don't look at it at all other than that in first year, because it's just beyond the scope of it. When we get to second year, we're going to look at it in more detail, and third year and fourth year, we're really going to tease it out and see how we can make programs that don't fall over. Okay, so if you have a piece of code you submit to me and you're worried because it asks for 3 numbers, but when you enter in a character, it crashes, that's something you shouldn't be worried about. That's beyond the scope of what I've asked you. You won't lose any grades for it, because I'm assuming, again, that you've got friendly, helpful user. Okay, we'll try a bit. Okay, let's do another example. Before I move on, does anyone have any questions? That's debatable. Right, okay.
No, I want just to make sure about the node, because kind of, yeah.
Yep. Okay, so we would only use, there are going to be scanner, random, file, print writer, buffer. There are going to be 5 to 6 scenarios across the entire first year where you will have to use the new keyword, and they will be for very, very specific things. So whenever you want to create a way of getting input from the keyboard, you're going to have scanner, whatever we're going to call it, is equal to new scanner system.in. Okay? For me, I wouldn't have any problem if line number 10 you just memorized and put into your code whenever you needed you to have a program that had user input. The only thing that would ever change on that line for you would be this here. If you didn't want to call it KB, you want to call it keyboard or input or user input. But that's just the name. That's just how you're going to refer to it. When we look at the random number generator, when we look at file access, and when we look at, actually there, we have random numbers, user input from the keyboard, and file access are the only times you will need to use it. And for all of the first semester, it will be this, and it will be the random numbers, which I'm going to show you next week. Okay? Any other questions? Okay, so what I'm going to do before we break up is I am going to take 2 of the questions that we had a look at last week. Okay, so these are questions we've already done, and I'm going to rewrite them to allow for user input. Okay, so the first question I'm going to take is going to be actually question 1 from your worksheet. We're trying to calculate the number of seconds in the days, hours, and minutes. And rather than hard coding in that value, I'm going to allow the user to enter in the value that we want. So let me see where I find that. Quick access. It's not there. Go up. Part-time. 3. Nope, it wasn't that one. Oh, it's in the full-time one, so I'll steal it from there. And this one was called. Oh, that's not it either. But we're going to come back to that one in a moment. That one either. Oh, for God's sake. Don't need that, don't need that. Okay, I'm just going to delete out the bits we don't need from this. Actually, do you know what? I won't. I'll leave it this. I'll talk through this code, and then for the cylinder question, I'll actually add in all of it, okay? So here is what I've done with the full-timers today, which is I've taken the seconds question. So we're going to have 3 variables, day, hours, and minutes, and we're going to calculate in that total amount of time how many seconds that there are. And the example I gave you and the examples in the worksheet, I use a sample value of 1 day, 17 hours, and 34 minutes, which totals out to something around 149,000 seconds. So what I've done is I've added in at the very top my java.util command to allow me to have user input in this program. I have altered the values of my D, H, and M variables. I've just set them to 0 to begin with because I'm going to, in a moment, take in user input. I'm going to take in those values from the user. I have 2 variables here just to help me do my calculations. I have 1 variable which calculates the number of seconds in 1 hour. So it's 60 minutes multiplied by 60 seconds in each of those minutes, giving us 3,600. And then I have the seconds in a day, which is where I take the result of seconds in an hour, and I multiply that by 24, which gives me 86,000 and something. And once I have those calculations done, it allows me to quickly calculate a number of days, a number of hours, and a number of minutes. On line number 12, let's increase that, see it. On line number 12, I have used my scanner, and you can see here, this is written exactly the way it was in the last program. There's no need to change it. KB is a perfectly logical name to call my variable, which will take keyboard input. And everything else needs to remain the same, and the program doesn't work. Lines 15 through 20 are where I will take in the user input from the user, and I will put that into each of the 3 variables. So enter the number of days, and they enter an integer here, and we put it into D, enter the number of hours, and we put it into our variable H, and enter the number of minutes, and we put it into our variable M. Okay? So when line 20 is finished, the rest of the code is the same as our previous solution. Okay? The rest of the calculation is exactly the same. The only difference between this version and the version that I would have done with you in class is that rather than me actually typing in numbers into my code, and then if I wanted to show you it worked for other numbers, opening up the code, editing the code, saving the code, building the code, and running the code, is that the user is going to enter these values at runtime. And then the last couple of lines, so when we hit line 20, we are finished with our user input. So the remaining parts of that look the way they did previously, where we need to calculate how many seconds in a day multiplied by how many days that we entered in, how many seconds in an hour multiplied by how many hours we have, and how many seconds in a minute multiplied by 60, the number of seconds in 1 minute. But it's very similar. It works in a very similar way to how our previous program works. There's a huge amount of similarity here. Let me quickly just save this to the desktop so it will run. So let's go and look at the top. Let's actually put them side by side. There. Okay, you won't be able to see everything, but we'll give you a minute. The top line of code is going to be our import statement. It's the same in both programs. On line number 10 here, zoom this out a little bit. We have our scanner, and on line number 12, we have our scanner. Okay, and they're written exactly the same. Scanner KB is equal to new scanner, open our brackets, system.in, semicolon. And then when we take our user input, we prompt the user. And actually what I'll do in this is I'll remove the prompts to show you how terrible it looks. But we prompt the user, and how we take in the information is exactly the same. KB.nextInt, because we're taking in integer values here. The next example I'm going to do, we're not going to use integer values, we're going to use double values so you can see how that works. So the programs are very, very similar in the new stuff we've had to add. We add one import statement at the top to say, here's how we get our user input, how we get access to it. We add one statement around where we declare our variables that allows us to use user input. And then whenever we need to actually get the user input, we use kb.nextInt. And it drags it in from the keyboard into our program. So let's have a look at running this code. Just go to view. So save that. Go here. Go that. Java C seconds. And then I got Java seconds. Okay, so enter the number of days. Let's go with the one that we had. So it's 1 day, number of hours, 17 hours, number of minutes, 34 minutes. Okay, so when I press enter now, I will have finished line 20 of this code. That's where I am now. It's just paused, waiting for me to use the user input. So when I hit enter now, there's no more user input required in this. It can take the values that I've entered in, which has been stored in D and in H, and as soon as I press enter, it can be stored inside M, and I can calculate the rest of that calculation, which gives me my 149,000. Okay, and if I were to run it again and enter in 2 days and 15 hours and 58 minutes, it will calculate that for me. If I run it again, I enter in minus 2 days, which is a ridiculous number, 450 hours and 67 minutes, it calculates that for me. Okay, so the calculation remains the same. The values are the only things that are changing here, and because the values are the only things that are changing, they're the only things that we need to take user input from. Okay, last question that I'll do before we break. Or I'm aware it's 1:45. Do you want to take a coffee break now and then we'll do the last question and get back? Or do you want to keep going and keep going? All right, let's keep going. There was a very quiet response, and the people who did respond said keep going. Let's go with that. Okay, so save as. I'm going to save this on the desktop. Okay, this is actually a really good example here, because here I haven't even used variables in this solution, so I'm going to need to add in user input and I'm going to need to add in variables. Okay, so this is my cylinder question. The top one there is the formula for my volume of the cylinder. That's pi r squared h. This one here is the wrapper area, so it's the surface area of just the kind of upright part of the cylinder, and the last one is the total surface area. So it's the upright part plus the bottom and the top. So what I'm going to do is I'm going to add in my variable bits first, and then I'm going to add in my user inputs. I'm going to do two passes through this program. So the first thing I'm going to do is I'm going to create double variables, because I need decimal points here. You can see I've got 3.1415 to represent pi. I've got 3.5 here representing my radius. I've got 10.5 representing my height. So I'm going to create a double. Let's spell it correctly. There we go. Pi. I'm going to set that equal to, pi is nice because it never changes, so I'm just going to set that equal to that. What I can do now is I can replace this with the word pi, this with the word pi, this with the word pi, and this with the word pi. And anywhere after line number 3, where I use the word pi, it just, when it's running it, when it's actually running the program, it just replaces it with the value, 3.1415. I'm going to create another variable here. There's also going to be a double, which will be equal to h. And that, for the moment, I'm going to set equal to 0, because we want to have user input eventually. But I can go back through here, and anywhere where we have 10.5 in this equation, I can replace that with h. Now, at the moment, that would ruin our calculation, because 0 multiplied by anything is a 0. But once we take user input, it will allow us to vary the size of the cylinder we want to find. The original question itself didn't give you the radius, it gave you the diameter. So let's use diameter. Let's say double D is equal to 0 to begin with. And then we're going to say double, or is going to be equal to D divided by 2. And I've used 2.0 to force it into a normal division where it will give me a decimal point rather than that div and mod scenario that we saw 2 weeks ago. And then what I can do here is I can replace that with OR, that with OR, that with OR, that with OR. Now, so first of all, my calculations are a lot neater because I've got rid of all the numbers except for in lines 3, 4, 5, and 6. When we're down here where we have those variable elements, pi and radius and height, I've just replaced them with symbolic representations, with letters to represent them. And now, unfortunately, you start to see why this looks a lot like calculus, because it is. It's a combination of calculus and algebra. That's what programming is. Sorry. Okay. I'm actually going to try to simplify this even further. I'm going to create 3 other variables. I'm going to create a variable called volume, a variable called wrapper area, and a variable called surface area. And they're going to hold each of these calculations here. So I'm going to create, these will all be double as well. So double volume. Volume is going to be equal to this. And then I'm going to create double, let's call it wrapper. And that is going to be equal to this. And so here I can write volume. And here I can write wrapper. And then the last one I have is that. That's going to be double surface area. And that's going to be equal to this. And then here I need to write surface area. So I'm almost finished at this point. This is functional. Once I change the value for D and for H, this will work exactly as the previous version. So if I put in 10.5 here and 7 here, I will get the same answers. But I'm not going to, because I'm now going to do another pass through and show you where I can put in my user input. I can get those values populated from the user. So go up to the top. Our first line now becomes import java.util.asterisk. That's the first thing we need to do. The second thing we need to do is to declare a scanner. So I'm going to go scanner KB is equal to new scanner system.in. And the third thing I need to do before I try to calculate these, because even now, lines 10, 11, and 12, if I try calculating them, they're going to give me 0 as the answer because a lot of the variables are still set at 0. I need to actually, in between here, is I need to take in the user input. I need to take in 2 things of user input, and I'm lazy, so I'm going to go back to here. I'm going to take in these 2. And I'm going to put them in here. And this is going to be entering the diameter. And enter height. Okay. So now I have a program that might work. I have a program that has variables and has user input. So I can take the values in from the user, I can store those values in the user input, sorry, not the user, in the variables, and then I can use the values inside those variables to calculate the results of my equations. So let's pick the same as what we had in the original one. The diameter of this cylinder was 7, and the height of the cylinder was 10.5, 10.5. So let's save this. Let's go here. This is Java C. Question 4b. Okay, right. Okay, so I have an error there where I'm missing a semicolon. That's simple to fix. Save. Run again. Okay, now. So enter the diameter. And again, we have nice prompts here. Hey, look, the user's been told what we need to do. So the diameter was 7. Great. Enter the height. The height was 10.5. It's crashed again. Okay, so let's see. All right, so line 13, then it goes back up, it goes back up, it goes back up, it goes back up. And the error is ultimately input mismatch exception.
That in instead of double.
Very good. I was wondering who would notice it. Genuinely, this is one of the ones I did on purpose. But this highlights two things. First of all, it highlights the flaws that you might encounter if you're really set on copying and pasting. I was lazy. I copied and pasted rather than writing it out. And I didn't double check what I copied and pasted, so I missed the fact the previous example used ints and this example uses doubles. The second thing it highlights is that you need to be specific on where you're taking information from or what way you're taking information in. The last two examples we did, they were integers. It was only integers we were using in those problems. They were all whole number numbers. In this example, we have the possibility of doubles, of decimal point numbers. And because of that, we need to make sure that we allow for decimal points to be added in. So this becomes next double, and this here becomes next double. So let's save that again. Actually, I'm going to comment out the prompts to the user so you can see what this looks like. See us there. No, sorry. Us. There, that one. Okay. Now, you can understand why this is frustrating for a user to see. My program is running, and it's just going to sit there until you enter something in. Now, question 4b is not a particularly descriptive title, so I don't really know what's been expected of me here. Depending on what age you started using computers, one of my first experiences with computers was a game called Zorg. So I would usually start typing something like hello, and that would crash the program. Because I started typing to it, thinking, oh, maybe it wants some sort of communication and it's going to explain to me what happens. And no, that doesn't give me any information there. So let's get rid of these, save it, run it again. Now, much more sensible. Enter your diameter, 7. Enter your height, 10.5. Interesting. Right, let's have a look at this. So, remember I said these calculations need to be done after you get your input? I probably also should have done the calculation for getting your radius after your input when you've got your diameter. Otherwise, it's 0 divided by 2. And since radius is used so much in these calculations, that's why we have. So we'll set that equal to 0. And then here, when the input has been got, we're going to say or is equal to the remainder of that. Okay, so this is going to be our calculations. Save that again. Run. Okay, so diameter is 7, 10.5 code. And now, finally, we have outputs that are really similar to when we did this in class, where we were just using the values themselves, or we were just using the variables holding the values. We have 404.075, and we have 230.9, and we have 703.86. Again, slightly off what Google give us, but remember, Google uses 12 digits of accuracy on their pi. We're using 4, which is massively going to alter what our calculation comes out with. But I can run this again. So that's our normal suit tin there. 7 units in diameter, 10 in height. Maybe I want to expand, and I also want to run pineapple tins, which are much wider, but the same kind of height. So maybe I've got 10.5. They're kind of almost cubes. They're 10.5 diameter and 10.5 in height. It'll give me the outputs to those. Maybe I want to make tuna tins, which are still quite wide but much shorter. So I would have my diameter being, let's say, 15, and my height being 5. And it gives me those values there. Maybe I want to make Pringles tins. So we have a really high height and we have a normal enough diameter. So our diameter might be still 7 units, but our height might be 20. We get those calculations there. So in each of those 4 or 5 examples I've done, I didn't edit the code. All I had to do was run that program again and enter in the criteria, tell it what the diameter is and tell it what the height is, and it was able to calculate everything else because my formulae has matched up. And all I was doing is I was changing the variable values. Does that make sense? Okay. Let's take a break. I'm going to upload the couple of examples I've done here onto the OneDrive. It is now 8 o'clock, so let's come back at 8:15. If you have any questions at 8:15, we can work through them then. Otherwise, you can use the remaining time for today's lab to go through. You should be able to do the first 4 questions on that worksheet at this point. So you should be able to work through that if you want. If you want to head off early to get an early night out of these 12 weeks, well, then you can do that as well. All right, guys, so I will see you after the break.